Stoichiometry, we will compute for the number of, or for the amount of the reactants, or even the amount of the product, pwedeng in terms of moles or in terms of mass. Now, so in terms of the calculating the masses of reactants and products in reaction, so cardinal rule, we need to have a balanced equation or balanced chemical reaction. So, kailangan importante na meron kayong balanced chemical reaction kasi pag wala, hindi kayo makakapag-compute ng tamang amount ng reactant and amount ng product. Then we can convert the known mass of the reactant. So, dapat given tayo ng known mass as much as possible, isa, either mass of reactant or product. Then, pwede natin siya convert in terms of moles. Then, we can connect the moles of reactant to another mole of reactant or moles of reactant to moles of product. Then, we can actually convert it papuntang in terms of mass using molar mass. So, we will use the balance equation or balanced chemical reaction to set up appropriate mole ratio. Later on, I will show you how to create a mole ratio. Then use the appropriate mole ratio to calculate for the number of moles of desired reactant and then convert it in terms of, convert the moles papuntang grams. So, dito, yung importante, the heart and soul of the calculation for the stoichiometry is the mole ratio. Now, so this is actually the schematic diagram in terms of the calculation. So if ever ang given sa atin is in terms of the mass of known substance, sabihin natin pwedeng nasa reactant to, this is mass, then convert it in terms of moles. So we will use molar mass. So gagamit tayo ng gram per mole dito. So kung dito mass, di-divide natin siya sa gram per mole para makakuha tayo ng moles. Then we will use the mole ratio, mole of desired substance over mole of known substance. So manggagaling siya sa balanced chemical equation or balanced chemical reaction. Then once na gumamit tayo ng mole ratio, automatic kasi magkakaroon tayo ng moles ng desired substance, yung hinahanap natin. Then, if I want to convert the moles sa puntang grams, gagamit ulit ako ng gram per mole or molar mass ng substance na hinahanap natin. Okay? So, for a balanced chemical reaction, let's say 4Fe plus 3O2 will give you 2Fe2O3. Now, I can say, for every 4 moles, yung mga coefficient natin, pwede na natin siyang gamitin in terms of mole. For every 4 moles of Fe, mag-react siya sa 3 moles ng O2. Sa 4 moles ng Fe, pwede din siyang mag-produce ng 2 moles ng Fe2O3. Okay? Sa 3 moles of O2, magre-react siya with 4 moles of Fe, iron. And sa 3 moles ng O2, magpuproduce siya ng 2 moles ng Fe2O3. Now, to come up with the mole ratio, I can say 4 moles of Fe is stoichiometrically equivalent sa 3 moles ng O2 and stoichiometrically equivalent din siya sa 2 moles ng Fe2O3. Okay, so kung halos equal silang lahat, then I can write 4 moles of Fe over 3 moles of O2. This is your mole ratio. Para siyang conversion factor. Then, pwede ko na sabihin 4 moles of Fe over 2 moles of Fe2O3. 3 moles of O2 over 4 moles of Fe. 2 moles of Fe2O3 over 4 moles of Fe. 3 moles of O2. Equivalent siya or over siya sa 2 moles of Fe2O3. And 2 moles of Fe2O3 over 3 moles of O2. So we can use the mole ratio based on the coefficients that can be found in a balanced chemical reaction. Okay? Now, so let's have an example. Mole-to-mole stoichiometry muna tayo. So, kumbaga sa diagram, ito lang muna papansinin natin. Wala tong mass of substance, known substance, and hindi ang target natin ay mass of desired. So, meron tayong mole of known substance and meron tayong mole of desired substance. Now, so dito importante si mole ratio. Siya magiging heart and soul ng computation natin for stoichiometry. So, example, how many moles of Fe2O3 from 6.7 moles of Fe which is made to react with O2? So, ang hinahanap natin ay moles ng Fe2O3. Ito, ang unknown. Given sa atin ay 6.7 moles of Fe. 6.7 moles of Fe. Now, so we need to balance this, the chemical equation or chemical reaction. So, 2 oxygen, 3. Sabi ko nga, gawin natin siyang even, so times 2. So, ito naman, kasi magiging 6 to, oxygen, times 3, O2. So, 4 ng Fe natin dito, so times 4. So, this is now your balanced chemical equation. Now, so, since moles of Fe ang given natin at ang tinatarget natin, desired natin ay Fe2O3, so dapat ang mole ratio natin has something to do with iron and Fe2O3. So, pwede kong sabihin, 2 moles of Fe2O3 equal siya sa 4 moles of iron. O 4 moles of iron equal siya sa 2 moles of Fe2O3. So, ang tanong dyan, sino lang ang nasa numerator at sino nasa denominator? Ganun ulit, cancellation of units pa rin tayo. So, kung 6.7 moles of Fe ang nandito, dapat yung baba ay moles of Fe din. So, 4 moles. Yung nasa taas, dapat yung counterpart, which is 2 moles of Fe2O3. Since siya din naman ang hinihingi sa atin. So, cancel the mole of Fe, moles of Fe. So, simplifying this one, we will have 6.7 times 2 over 4. So, we will have 3.35 moles of Fe2O3. So, this is now your answer. So, this is actually what we call the mole ratio. Okay? Next. So, let's have this one. Let's say we have 3 moles of sodium is made to react with Cl2 to produce NaCl. So, we need to find for the moles of Cl2 and NaCl. So, ito yung 3 moles. Unknown to, kailangan natin mahanap yung moles ng Cl2 and moles ng NaCl. So, paano natin siya gagawin? Balance muna natin yung chemical reaction. So, isang sodium, technically, as of now, balance siya. Si chlorine, dalawa, dito isa. So, times 2. So, 2 chlorine, 2 chlorine. Kaso damay si sodium, dalawa ni sodium, so times 2 naman din dito. So, we'll have 2Na plus Cl2 will give you 2NaCl. Now, so, kung kakailanganin ko, ang hinahanap ko ay mole of Cl2, dapat meron akong, pwede kong masabi, for every 2 moles of Na, equivalent siya sa 1 mole of Cl2. Then, for every 2 moles ng Na, siya yung given eh. Meron akong 2 moles ng NaCl. So, get first the mole of Cl2. So, 3 moles of Na, this is your given. So, kung ito yung given natin, ito yung unit natin, dapat yung baba, ito din, mole of Na. Cancel. Cancel. So, automatic, yung isa, yun yung numerator natin. Actually, kung sino hinahanap mo, dapat yun yung numerator. Okay? So, mole of Cl2. So, 1 and 2, these are your coefficients in a balanced chemical reaction. So, itong 2 na to, manggagaling to dito. Yung 1 mole, manggagaling siya dito. Coefficient ng Cl2. So, 3 times 1 over 2 will have 1.5 mole of Cl2. Okay? Then, for the mole of NaCl, so, given tayo ulit ng 3 moles, yan ang gagamitin natin, 3 moles of Na. So, dapat yung baba, moles of Na din. So, sasama natin yung 2. So, nasaan ang galing to? Ito yun. Galing siya dito. Coefficient ng Na. So, moles of Na, moles of Na cancel. So, yung taas, moles of NaCl. So, saan ang galing yung 2 din dito? Galing sa coefficient naman niya in a chemical reaction. Balance chemical reaction. So, 3 times 2 over 2. So, we will have 3 moles of NaCl. So, that's it. That's how you compute for the stoichiometry for mole-to-mole relation, mole-to-mole stoichiometry. So, it's very important to have a balanced chemical reaction in order for you to set up the mole ratio na kailangan sa problem. Okay? Now, what if we have mass-to-mass stoichiometry? So, actually, dito yung medyo tricky na part. So, for the mass-to-mass stoichiometry, mass ang given natin na known substance, yung desired mass din. So, kailangan natin gumamit ng molar mass dito. So, it's very important to calculate for the molar mass of every compound in a chemical reaction, lalo na kung hinahanap lahat ng masses ng bawat compound or molecule or element in a chemical reaction. So let's have this one. Consider the following reaction, P4 or the phosphorus plus O2, kung sabihin, binurn siya sa oxygen gas. And the final product is P2O5, diphosphorus pentaoxide or pentoxide. So, according to the problem, meron tayong 6.25 grams of phosphorus here is burned. So, what mass of oxygen gas, so we're after for the grams of O2 here, does it combined with? Also, calculate the mass of P2O5. So, we're after for the mass of P2O5. So, gawin natin in terms of grams na lang ang mga unit ng masses natin. So, the chemical equation is already balanced. So, we have 1P4 plus 5O2 will give you 2P2O5. Okay, so, atomic weight ni phosphorus ay 31 gram per mole. Atomic weight ni oxygen ay 16 gram per mole. Okay, so here are your molar mass or molecular weights. So molar mass of P4, this is 124 gram per mole. So 31 times 4 because of the 4 here. Ito yun. Molar mass of oxygen, this is 16 times 2. This is 32 gram per mole. And then the molecular weight of P2O5, this is 142 gram per mole. Okay, now, so, bakit ang dami kong parang kinuha natin lahat ng molar mass? Kasi gagamitin natin siya pangkuha ng mass ng O2 saka mass ng P2O5. Okay, so here, this is actually the equation. So, for on cancellation of units tayo dito. So, ang given sa atin ay 6.25 grams. Ang atomic weight na to, usually kapag ako naglalagay, ang atomic weight na nalagay ko sa baba. So, ang atomic weight ni P4 ay 124 gram per mole. Hindi ko na nasusulat yung unit. O2, this is 32. Then P2O5, this is 142 gram per mole. So we're after for the mass of O2 and then P2O5. Okay. Now, so 6.25 grams of P4. Then convert it in terms of moles of P4. So yung 124, so pwede ko kasi sabihin for every 1 mole of P4, equivalent siya sa 124 grams of P4. For every 1 mole of oxygen, O2, equivalent siya sa 32 grams of O2. And for every 1 mole of P2O5, equivalent siya sa 142 grams of P2O5. Okay? Now, so 6.25 grams of P4, converted in terms of mole of P4. So, kung ito yung grams of P4, so dapat ito nasa denominator. So, ito nasa numerator to. So, cancel the grams of P4, grams of P4. Now, ang unit na natin dito ay in terms of mole of P4. Now, yung gitna palagi, siya yung mole ratio. So, kung mole of P4 to, dapat yung baba mole of P4. So, for every 1 mole of P4, ilang moles ng O2? We have 5. So, 5 moles of O2 over 1 mole of P4. Cancel, cancel. Now, since I have moles of O2 converted papuntang mass. So, kung mole to ng O2, dapat, ito yung moles na nasa baba, dapat ito yung nasa taas. So, we have 32 grams of O2. Always remember, every time I use the molecular weight, yung mga values natin in terms of grams, palaging 1 mole ang katumbas niya. Hindi 2 moles, hindi 3 moles, 1 mole. So, 1 mole of O2, 5 moles of O2, so multiply natin siya sa 32 grams of O2 per 1 mole of O2. So, simplify this. So, 6.25 times 1 over 124 times 5 times 32. So, we will have 8.065 grams of O2. That's it. Okay. So, this is now the mass of O2. So, ito, 8.065 daw yung mass ng O2 natin. Now, for the grams of P2O5, so start ulit tayo sa 6.25 grams. So, 6.25 grams of P4, so dapat yung baba, grams of P4 din para mag-cancel to, tsaka to. So, ito nasa baba, ito nasa taas. So, meron ka ng mole of P4. Now, yung gitna, mole ratio yon. So, kung ito, mole of P4, dapat yung baba mole of P4 din. So, for every 1 mole of P4, meron kang 2 moles ng P2O5. So, 2 moles of P2O5. So, cancel to, tsaka to. So I know the moles of P2O5 now. So meron akong moles ng P2O5, convert natin siya papuntang mass ng P2O5. So gagamit ako ng molar mass. So multiply tayo. So kung ito yung mole ng P2O5, dapat yung baba, mole of P2O5, ito yun. So dapat ito nasa taas. So 142 grams of P2O5 ang nasa taas. So cancel the mole of P2O5, mole of P2O5. Okay. So, how are we going to calculate this one? So, 6.25 times 1 over 24 times 2 times 142, we will have 14.315 grams of P2O5. Okay, so this is the amount of oxygen gas na needed to burn the P4 and magpuproduce siya daw ng 14.315 grams of P2O5. So, si 6.25 students, makikipag-react siya sa 8.065 grams of O2 and then magpuproduce siya ng 14.315 grams of P2O5. Okay, now, this part, I will teach you how to compute for the stoichiometry without going through cancellation of units. Bigyan ko kayo ng technique. Okay, so I'm going to give you this technique. So, let's say the mass of desired equal siya sa mass ng known, given mass of known substance, then times, ito isang multiplying lang tayo, isang multiplication lang tayo. Burahin ko lang yung line. Okay. So, okay. So, yung baba, molecular weight or molar mass ng known substance, then yung coefficient niya in a chemical reaction. So, this is for known. Kaya lalagay ko K ha, for known. Then, sa taas naman, molecular weight niya, then times the coefficient naman. So, kung ito yung known, yung desired, yung nasa taas. This is the D. Okay? So, actually, ito ang gagamitin natin. We can use this. You can use this formula for very simple calculation to find for the mass of the reactant or mass of the product based on the given mass. Okay, so let's go back here. We're after for the grams of O2. So palabasin natin si 8.065 grams of O2. So, given tayo 6.25 grams of P4. So mass of O2 is equal to start tayo sa mass ng known. So, this is 6.25 grams of P4. So, kung ito grams of P4, dapat yung baba puro P4. Now, times, so denominator muna tayo. Ako usually ginuna ko yung denominator kasi yun yung pang known, yung taas yung desired. Okay, so sabi dito molecular weight daw ng known. So, anong molecular weight ng P4? Ang molecular weight ng P4 ay 124. So, sulit ko na lang. No need to write for the unit if you're using this. So, 124, then times. Anong coefficient ng P4 in a chemical reaction? Coefficient ha? Ang coefficient niya ay 1. Okay? Coefficient niya ay 1, so times 1. Dito. So, we're done. We're done with the known. So, punta na tayo ng desired. So, si desired, si O2, siya yung desired natin. So, ang desired natin, ang molecular weight niya ng O2 ay 32 gram per mole of O2. So, this is 32, then, times, coefficient ni O2 in a chemical reaction. Ang coefficient niya ay 5. Okay? So, times 5. Okay. So, simplify. 6.25 grams of P4 times 32 times 5 divided by 124 divided by 1. So, final answer is, kung anong unit nyo dito, yun din magiging unit natin sa labas. Pero this is not P4 anymore, this is O2. So the answer is, this is 8.065 grams of O2. You can check this using your calculator. Okay? So that's it. So that's the mass of O2. Now, let's calculate for the mass of P2O4, P2O5. Mass of P2O5 equals, so copy this, 6.25 grams of P4, then times. Okay, so this is 124 again, kasi P4 naman ang pinag-uusapan natin, atomic weight, molecular weight or molar mass. So 124 grams of P4, and then ang coefficient niya ay 1 in a chemical reaction. So times 1, then, ano ang molecular weight or molar mass ng P2O5? Ang molar mass niya ay 142. Tapos ang coefficient niya ay 2. So this is 142 times 2. Okay, so double check natin 124 grams of P4, ang molecular weight ni P4, and ang coefficient niya ay 1. Tapos si P2O5 ay 142 grams per mole of P2O5. Tapos ang coefficient niya ay 2. So, 6.25 times 142 times 2 all over 124 over 1. So, the answer here is 14.315 grams of P2O5. So, P2O5. Okay. So, double check. You can actually double check it using your own calculator. So, halos pareho lang. Ito, dito, 8.065 grams of O2, tapos 14.315 grams of P2O5. Ito din, 14.315 grams of P2O5. So, you can actually use this formula. This is only good for mass to mass, ha? Mass to mass lang to. So you can actually use this formula. This is only good for mass to mass stoichiometry. This is good for mass to mass stoichiometry. Actually, kung ito naman mole of desired, tapos given tong mole na to, tanggalin nyo lang yung molecular weight coefficients lang ang labanan. Makukuha nyo na rin yung mole ng desired. So, ito naman, pas na pag-mass, kaya kailanganin nyo ng mga molecular weight. Molecular weight ng desired, molecular weight ng known. Okay? Now, so, 8.065 grams of O2, 14.315 grams of P2O5. Okay, so, P4 plus 5O2 will give you 2 P2O5. So, ang given daw sa atin ay 6.25 grams. Tapos ito ay 8.065. Okay. So, this is 8.065 grams. Tapos ito, 14.315 grams. Okay. So, for the reactant, so 6.25 plus 8.065. Just to check, this is actually part of checking kung tama ba nakuha nyo. 6.25 plus 8.065, we will have, this one, we will have 14.315 grams, which is equivalent also sa product side, which is 14.315 grams. So, pareho lang. So, this is actually how we illustrate the law of conservation of mass using stoichiometry. So, 14.315, ang papasok, total nito all in all 6.25 grams plus 8.065. Pag pinagad mo, 14.315. So, dapat lalabas siya in a chemical reaction na 14.315 din. So, it's very important to have a balanced chemical reaction kasi pag hindi nyo na-balance ang chemical reaction, hindi nyo mababalance din itong dalawang to. Okay? So, here, the reactant, 6.25, 8.065 for the O2, so we have 14.315 grams. For the product, we have 14.315 grams, and then compare the two since they're equal, product and reactant, therefore, we're following the law of conservation of mass. Okay? Now, let's have another example. So 50 grams of propane is burned with excess O2 to produce energy. So the following reaction is shown below. So we have C3H8 plus O2 will give you CO2 plus H2O. So calculate the amount in grams of oxygen gas needed to burn the propane. So propane, this is it. Also calculate the amount of carbon dioxide and water vapor. So this is in terms of grams, also in terms of grams. Now, so let's balance first the reaction. So this is a combustion. So tatlong carbon, isa so times 3. Then hydrogen, meron kang 8 dito. Meron kang 2 so times 4. 3 times 2 for the oxygen, we have 6. 4 times 1, we have 4. So add this 2, we have 10. 10 divided by 2, so we will have 5. So the balanced chemical equation is C3H8 plus 5O2 will give you 3CO2 and then 4H2O. Now here are the molecular weights rather for C3H8, H2O, CO2, and O2. So si carbon, ang atomic weight niya ay 12 gram per mole. Hindi ko na nasusulat yung unit. Then hydrogen, we have 1 gram per mole, and then oxygen, we have 16. So molecular weight or molar mass of C3H8, this is 44 gram per mole. This is the solution. Molar mass or molecular weight of H2O, this is 18 gram per mole. Then for the CO2, this is 44 gram per mole. And O2, we have 32 gram per mole. Now, so this is actually the cancellation of units. So 50 grams of C3H8 times 1 mole of C3H8 over 44. This is the molecular weight of C3H8. So cancel, cancel. Then, mole of C3H8, so dapat sa baba moles of C3H8 then. So this is what we call the mole ratio, students. So for every 1 mole of C3H8, we have 5 moles of O2. So ito yun. Cancel, cancel. Then, convert the mole of O2 to mass of O2. We'll use the molar mass of oxygen gas. So, kung mole of O2 to, sa baba mole of O2, so yung taas, yung value in terms of mass, we have 32 grams of O2. Cancel, cancel. So, we will have 181.818 grams of O2. Then, do the same for CO2. So, 50 grams of C3H8. So, grams of C3H8 sa baba to, cancel, cancel. This is molecular weight of C3H8. Then, sa taas yung mole. So, kung ito yung mole C3H8 nasa taas, so dapat susunod nasa baba siya para mag-cancel. The second multiplying factor natin is actually the mole ratio. So, for every 1 mole of C3H8, we have 3 moles of CO2. 3 based on the chemical coefficient of the chemical reaction. Now, so, cancel, si mole of CO2 kung nasa taas siya, dapat sa susunod nasa baba siya. Cancel to. We will use the molecular weight or molar mass of CO2 to convert mole to mass. So, kung nasa baba yung mole of CO2, dapat yung taas yung naka-mass. So, 44 grams of CO2. Okay, so we will have 150 grams of CO2. This is the answer. So, this is the mass ng CO2. Yung oxygen gas natin ay 181.818 grams of O2. Now, last for the grams of H2O. So, we have 50 grams of C3H8 divided by times 1 mole of C3H8 over 44 grams of C3H8. Cancel to, tsaka to. So, yung mole nasa taas, so dapat susunod nasa baba siya. So, cancel. Ito. So, the second one, again, is actually the mole ratio. So, for every 1 mole of C3H8, we have 4 moles of H2O. So, nasa taas yung mole ng H2O. So, kung nasa taas siya, yung pangatlong multiplying factor natin dapat nasa baba na siya. Para mag-cancel, cancel. Then, kung mole to, papuntang mass, we need to use the molecular weight. So, yung 18 grams yung nasa taas. So, we will have 81.818 grams of H2O. Okay? So, that's how you compute using the cancellation of units. Now, can we use this equation, this formula? Actually, yes, we can. So, mass of the known, mass of the substance, mass of the desired I'll just write it again. Mass of the desired is equal to mass of known. This is your given. Then times, so this is molecular weight times coefficient of the known substance, so K, then molecular weight times the coefficient in a balanced chemical reaction, then this is your desired. Okay, so we'll use this formula. Now we're after for the O2. Okay, for the mass of O2 equals. Okay, so we'll start with the grams of C3H8. So 50 grams of C3H8. So this is your known. Known siya. Ang molecular weight ng C3H8 ay 44 grams of C3H8 per mole of C3H8. So 44 ang kanyang molecular weight. Ang coefficient niya in a balanced chemical reaction, so kunin na natin ha, ang coefficient niya ay 1. Okay? Si oxygen, ang coefficient niya ay 5. Tapos ang kanyang molecular weight ay 32 gram per mole. So ito times 1. Tapos sa taas, this is the desired, O2 na to ha. So this is 32. Then ang kanyang coefficient sa chemical reaction ay 5. Okay, so simplify this. So 50 grams times 32 times 5 divided by 44 divided by 1. So this is 18.818 grams of O2. So you can actually check using your calculator. Sorry, this is 181. Okay? So double check nyo. You can double check it using your calculator. So halos same sila dito. Same siya. So you can actually use this equation. Then next, mass of CO2. So we'll start with 50 grams again. 50 grams of C3H8. Then times, okay, ubrahin ko lang to. Nakayan ko lang. Times, okay, so ganun ulit. Hindi naman magbabago itong denominator. So this is still 44. This is the molecular weight of C3H8. Yung 1, yung coefficient niya in a chemical reaction. Ito yan na, yung 1. Dito yan na manggagaling. 1. Hindi na natin sinulit lang. Then, yung taas, ang molecular weight ng CO2. So, 44 then ang molecular weight niya. Then, ang coefficient ni CO2 in a chemical reaction, this is 3. 3 CO2. So, we have times 3. Okay? So, the final answer is 150 grams of CO2. Okay? So, that's it. That's for the amount of CO2. Now, let's go for the amount of H2O. Okay, so the amount of H2O, the mass of H2O is equal to, so start ulit tayo sa 50 grams. So 50 grams of C3H8. Then, known tayo, known substance muna tayo. So ang molecular weight nito ay 44 gram per mole. Ang kanyang coefficient in a chemical reaction ay 1. Tapos, punta na natin si H2O. Okay, ang molecular weight ni H2O ay 18 gram per mole. Ang kanyang coefficient in a chemical reaction ay 4 moles of H2O. So, 18 gram per mole, then times 4 for the coefficient. Okay. So, simplify this one. So, this is 50 times 18 times 4 divided by 44 divided by 41. So, we will have 81.818 grams of H2O. Okay? So, that's it. That's how you compute for the mass of H2O, mass of mass of CO2, and mass of O2. Now, so, kunin natin so we have C3H8 plus 5O2 will give you 3CO2, then plus 4H2O. Okay. Ang amount na C3H8 natin ay 50 grams. So, this is 50 grams. I'll change the color of the font. Gawin ko na lang red. So, this is 50 grams. Ang O2 natin ay 181.818 grams. Then, si CO2 natin ay 150. So, this is 150 grams. Tapos, si H2O natin ay 81.818 grams. Okay. Add this two. So, 50 plus 181.818 grams. Sorry. Wala na yung, tanggalin ko na lang yung unit. Maglagay na lang ako ng values. Kasi hindi ako naglagay sa 50 eh. So, dapat equal siya sa 150 plus 818 grams. So, dapat equal siya. Kung mag-equal siya, ibig sabihin, tama ang nakuha natin mga sagot. Okay? So, checking. So, 50 grams for C3H8. O2, this is 181.818 grams. Then, a total of 231.818 grams. Total ng reactant side. Then, for the CO2, this is 150 grams. Then, for the H2O, this is 81.818 grams. So, add this two, we will also have 231.818 grams. So, since pareho silang dalawa, therefore, it follows the law of conservation of mass. So, tama yung nakuha natin yung sagot sa O2, CO2, and then H2O. Okay, I hope that's clear in terms of the computation. So, next, a 5 grams of zinc metal is immersed in an HCl solution. So, determine the amount in grams of zinc chloride and hydrogen gas produced. So, the chemical reaction is shown below. So, zinc plus HCl will give you zinc chloride plus H2O. So, balancing natin, isang zinc balance. Hydrogen, isa dito, dalawa, so times 2. So, si chlorine, dalawa din dito, dalawa si chlorine. So, damay naman siya in terms of balancing. So, the balanced chemical reaction, we will have zinc plus 2 moles of HCl will give you 1 mole of zinc chloride, then 1 mole of H2. So, 1 mole ng zinc, 2 moles ng HCl, 1 mole ng zinc chloride, and 1 mole ng H2 gas. Okay, so, ang atomic weight ni zinc ay 65.4 gram per mole. Si hydrogen ay 1 gram per mole. Si chlorine ay 35.45 gram per mole. Okay? Now, so, we're after for the zinc chloride, yung mga products natin, we're after for the zinc chloride and H2. No need to compute for the HCl. So, pinakita ko lang din naman balance, pero we're not after for this one. So, halos 1:1 lang ang coefficients natin. So, this is the atomic weight of zinc, molecular weight of zinc chloride, so 65.4 times 1 for the zinc. Chlorine is 35.45 times 2 because of the 2 as the subscript. So, we will have 136.3 gram per mole. Then, we have hydrogen, 1 times 2. Okay. So, we can use the stoichiometry, cancellation of units, in terms of getting the number of the product getting the mass of the product, which is zinc chloride and the H2 gas. Okay, so this is actually the equation. So again, 5 grams of zinc, this is the given. So we have 5 grams here. Unknown si zinc chloride and si H2. So 5 grams of zinc. So convert it in terms of mole. So gagamit tayo ng molecular weight. So kung grams to, dapat sa baba grams din. So yung taas magiging mole of zinc. Cancel. Then, kung mole of zinc dito, dapat sa baba mole of zinc din. Remember yung pangalawa, students, this is our mole ratio. So for every 1 mole of zinc, we have 1 mole of zinc chloride. So 1:1. Sila cancel, cancel. Then convert the mole of zinc chloride to mass of zinc chloride. We will use the molar mass. So mole of zinc chloride cancel. Cancel sa taas yung grams. So we will have 10.42 grams of zinc chloride. Then for the mass of H2, so 5 grams of zinc. So baba pa rin yung grams of zinc, cancel to, cancel. So taas yung mole of zinc. Then the second multiplying factor is your mole ratio. So kung ito yung mole of zinc ay nasa taas for the first one, the second one dapat nasa baba siya para na mag-cancel out. So for every 1 mole of zinc, you have 1 mole of H2. So kung itong mole of H2 ay nasa taas, dapat sa baba, sa susunod nasa baba siya. So cancel to, tsaka to. So yung taas yung molar mass niya, which is 2 grams. Yung magiging value nito is in terms of grams of H2. So 5 times 1 over 65.4 times 1 times 2, so we'll have 0.153 grams of H2. Okay, so can we use again this formula? Actually, yes, of course, we can. So mass of the desired, change the font color. So mass of the desired equals mass of the known substance times molecular weight, then times the coefficient of the known substance in the chemical reaction. So this is known, ha? Then sa taas yung desired. So molecular weight ng desired substance, then coefficient ng desired, ng B. Okay. Now, we're after for the amount of zinc chloride. Okay, so mass of zinc chloride is equal to 5 grams of zinc, then times, so this is 65.4. This is the molar mass, atomic mass, or molar mass of zinc, or atomic weight of zinc. 65.4, then the coefficient of zinc, this is 1, times 1. So, brain ko lang to. So, times 1 here. Then, we're after for the zinc chloride. So, ang molecular weight niya ay 136.3. At ang kanyang coefficient in a chemical reaction, this is 1. Okay. So, simplify this, we will have 10.42 grams of zinc chloride. Okay, so same siya dito. Now, let's go with the mass of H2. So, copying nyo lang. Actually, pag ganito, kukopying nyo lang din tong baba. So, we have 5 grams of zinc. Then, denominator muna tayo. So, we have 65.4 of zinc times 1 for the coefficient. Then, this is H2. So, we have 2 gram per mole, the molecular weight of H2. Then, times the coefficient of H2. Ang coefficient niya ay 1. So, times 1. Okay, so simplify this. So, 5 times 2 times 1 divided by 65.4. So, we will have 0.153 grams of H. Okay? So, that's it. So, halos same siya. Same din siya dito. So, you can actually use this. Basta, this is good for mass-to-mass stoichiometry. Okay? Actually, yung tawag namin usually dito is like a more of gravimetric factor. But, usually tinuturo siya to sa higher chemistry part. But, since we can use this for ease of computation. We can actually use this. So it's really up to you if you want to go or use this cancellation of units, or you can go with this formula. Okay? So this is the additional problem. I'm gonna leave this one to you to try to solve this. So the additional problem, so given down as 6.5 grams of copper sulfide. So this is 6.5 grams. Tapos si S8, siya yung magiging natin. What do you call this one? Octasulfur, this is your unknown, and this is also your unknown. So, halos pabaliktad lang din. So, still you can use this. So, this is your known substance. This is your desired. Known substance and then desired. So, just try to balance this one. So, this is the balance chemical reaction. I also included the solution here. But you can try to use the shortcut. Though this one, you can use this to check kung makukuha niyo yung mga sagot na nandito. Okay? So 5.192 grams of copper, and then for the octasulfur, we have 1.308 grams of octasulfur. Then another problem here, so dapat balance sila din to know kung tama yung sagot nyo. Okay, then you can also try this. So two problems you can try in order for you to check if you can actually use the shortcut formula, or you can actually go with the cancellation of units or the dimensional analysis. Okay, so this is also the answer. So these are the references, and then thank you so much for watching this video.